seems like. Maybe I'm only noticing the ones that equal C, but hey, that's an interesting trend they're doing here. The function f is given by here. Ax squared plus 12 over x squared plus b. The figure above shows a portion of the graph f. Which of the following could be the constants a and b? Alright. Well, if you're looking at this, we have a couple of things of information in the picture. We have a vertical asymptote, and here we have a horizontal asymptote. The vertical asymptote happens when the ratio, or this rational expression, I guess you could say, has a 0 in the denominator, but a non-zero in the numerator. And that seems to be happening here at 2. So when does x squared plus b equal 2? Or no, pardon me. When 2 equals x. So 2 squared plus b equals 0. So 2 equals x. And then what does b equal? 4 plus b equals 0. Then I guess b equals negative 4. Right, so b equals negative 4. And if I'm looking at all these answers, there's only one option with that. And it looks like a is also going to be 3. Well, that's kind of interesting. I mean, we could have maybe simplified that by looking at the a first, but I know for sure that the only one that has b equals negative 4 is d. So that must be the answer. Number 11, it disappeared again. What is the slope of the line tangent? Just the slope. Nothing else, just the slope at x equals 1. So it's really saying find f prime of 1, or find dy dx when x equals 1. Well, we got to start by finding the actual derivative of the function, and it's getting a little sloppy here. Notice that we have a high and a low. This is a quotient rule, and the derivative with the quotient rule is low d high, low times derivative of high, minus high d low, high times the derivative of the low, over the low times itself, low. So let's fill that in. The low is going to be x plus 1. The high is e to the negative x, and the derivative of that is going to be e to the negative x times negative 1. It's a chain rule. The derivative with respect to x of e to the u is really e to the u times du dx. The derivative of this power. That's why I get that negative 1. Then we got high d low. And the high is, what is the high here? It's e to the negative x times the derivative of the bottom, which is just 1. And then on the bottom we have x plus 1 times x plus 1. So here is my y prime, my derivative. Notice that I used f prime of 1, dy dx, and y prime. Does it really matter? No, they all mean the same thing. Because I'm just working it out here. I'm not actually writing a response for anything. Okay. But we need to figure this out when x equals 1. So y prime then at x equals 1 is 1 plus 1 times e to the negative 1 times the negative 1 minus e to the negative 1 times 1. And then what else do we have here? We got, on the bottom it's going to be 1 plus 1 times 1 plus 1. Let's simplify here a little bit. So we got a 2 times 1 over e. And we got a negative, so let's put that 2 with the negative, put those together. And we got minus, this second expression here is 1 over e, all over 4. Well, if I were to simplify that top piece a little bit more, I would have negative 2 over e minus 1 over e. That's really negative 3 over e over 4. Well, that's really like over 4 over 1, so I'm going to This is dividing fractions, so I'm just going to flip and multiply. That means I have negative 3 over e times 1 over 4, or negative 3 over 4e. Is that one of the options? Booyah! It's B. That's why we say booyah. Next, number 12. If f prime of x equals 2 over x and f of square root of e equals 5, then f of e equals, ooh, this is trouble. Let's see, there's our derivative. All right, we can do the antiderivative. The antiderivative, f of x, is equal to the antiderivative of f prime of x. And that's really going to, and then we're going to have a constant actually on the end there. And we're going to use this information here, f of the square root of e is equal to 5. That's going to help us find that constant. So the antiderivative then of 2 over x dx, that's really equal to 2 times the antiderivative of 1 over x dx. And the antiderivative of 1 over x dx is equal to natural log of x, and then we got plus c. So this is going to become 2 times the natural log of x plus c. So f of x equals 2 times the natural log of x plus c. And f times the square root of e is going to equal. Now I noticed something here. I'm thinking ahead because I see this 2 here, and I think it's actually going to help me if I move it up there. So this original function could also be written as f of x equals natural log of x squared plus c. Because now I'm going to have natural log of the square root of e squared plus c. And I know that that equals 5. Well, again, we simplify. Square root of e squared is just e, so it's natural log of e plus c equals 5. Natural log of e, those simplify. Those are going to become 1 plus c equals 5. And then c equals 4. So c equals 4. Does that help me? What's it really asking? It says f of e. Well, f of x is equal to natural log of x squared plus, and then c right here is 4. So f of e is going to be natural log of e squared plus 4. Well, that's the same thing as saying 2 times the natural log of e plus 4. Then I simplify natural log of e as 1. So it's going to become 2 plus 4, which equals 6. Duh. It's D. The answer is D. Next. Alright. We do have some things going on here. It actually looks like this is using a chain rule kind of thing. Like an embedded function. So let's see if we can do it the same style they're doing it. I notice that we have a u on the inside and then squared. So what I'm looking for then, well, that's kind of hard actually. Let's go ahead and multiply this out. We got x cubed plus 1 squared. Well, if I were to multiply it out, that's the same thing as saying x cubed plus 1 times x cubed plus 1. And that's going to give me x to the 6th plus 2x cubed plus 1. Now, that's my original inside piece. So the antiderivative of this, the antiderivative of x cubed plus 1 squared on the side. So the antiderivative of x cubed plus 1 quantity squared is the same thing as saying the antiderivative of x to the 6th plus 2x cubed plus 1. Well, this antiderivative is going to be x to the 7th over 7 plus 2x to the 4th over 4 plus 1x. So that becomes x to the 7th over 7 plus x to the 4th over 2 plus x. Is that a choice? Oh, plus c, of course. I can't forget the plus c's. It looks like it's b. Is that the same thing you see? Yep, I see it. Because this is really 1/7 and 1/2 and 1. So B is our answer. B is our answer. Ooh. When I see this, I want to tell you guys what I'm looking at. I'm looking at the limit as h approaches 0 of f of x plus h minus f of x all over h. And as I read that, I know what that actually equals. That's the limit definition of a derivative. That's really saying f prime of x. So if I can identify what f of x was originally, then I can also identify, pardon me, what f prime of x is. Well, it looks like that f of x here is really going to be e squared. It kind of looks like that, but it's not exactly that. It's saying that it's f of x is e to the x. And then f of 2 is really e squared. And it's asking us what's f prime of 2. Well, fortunately for us, if f of x is e to the x, then that means that's also the same as our derivative. Because f prime, or the derivative of e to the x, is e to the x. It's itself. It's the only function that actually does that. Excuse me. That means that the derivative is just e to the x. So f prime of 2 is really e squared as well. So that's kind of an interesting way to use this. I haven't seen that where they actually plug this in and do the h at the same time. It's a slightly different way of writing it. The answer would have been d, e squared. The sloped field is wavy. Cool looking picture here of certain differential equations shown above. Which of the following could be a solution to the differential equation with the initial condition y0 equals 1? In other words, it's saying y of 0 equals 1, so right here. So if I'm going to go through that line, what happens as I follow this path? Well, it looks like I go down on one side. Looks like I also go down on the other side. So what function kind of does this, where it flattens out across the bottom? That's kind of interesting to think about. What kind of functions have a horizontal line here but a bump in the middle? So we have to refer back to our knowledge of just general graphs. I can say that 1 minus x squared is out. How can I say that? Well, 1 minus x squared does have a bump in the middle, but it keeps on going down. It doesn't flatten out. It's supposed to be flattening out on each side. So that one's out. Cosine x does also have this bump in the middle, but then it starts to curve back up on each side and then have more bumps. And it doesn't look like it kind of flattens out here. A cosine would have gone further down like this. So that one's going to be out too. E to the x, well, e to the x would be, what would that be? E to the x is going to be just a simple exponential growth. This is e to the x. So that one's out too. The square root of 1 minus x squared, that's actually a half circle, because that's like saying y equals the square root of r squared minus x squared, where r equals 1. It's a half circle with r equals 1. So D is out too. So I guess E is the only one left. Now I know it's the answer, and there are other ways that we can look at that. But, you know, it's kind of interesting to see what would actually, how we came to this conclusion. It was mostly just by ruling out all the other ones. So the answer is E. If f prime of x equals square root of x minus 2, which of the following could be the graph for y equals f of x? Well, that means that at 2, I kind of have this weird thing going on, where before 2, like if I were to find like f prime of 1, that's going to equal 1. And if I'm looking at f prime of, what else are we looking at here? F prime of 3, that also equals 1. So at 3, I should see a positive slope of 1, and at 1, I should see a positive slope at 1. Where does that happen? Well, C is definitely out, because it's negative over here. And for a similar reason, B is definitely out, because it's also negative here at 1. Now, A is also out. This is just the function square root of x minus 2. So maybe that'll help us interpret whether D or E is our answer. So now let's kind of see what's going on. So if I were to plug in, if I were to look at this graph, I see that my slopes are positive, positive, positive the whole time, but they get slowly closer to 0 here. So they do actually hit a 0, but then they change back to the positive, 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 positive kind of action. Now, you would almost want to say E, but I'm almost a little more inclined to say D. And it's kind of interesting to really know why. But a lot of it has to do with looking at this function from two different sides. So, well, if I were to look at this function before 2 and after 2, because that's saying that f prime of x is equal to, let's see what we would have here, f prime of x is equal to x minus 2 when x is greater than 2, greater than or equal to, I guess you could say, and it's equal to negative x minus 2 when x is less than or equal to, or not less than or equal to, just less than 2. That's what absolute value really is. It's just a piecewise function. So if I'm taking the antiderivatives of this, that means I have, it's x squared minus 2x plus some constant. So this is equals f of x. And on the other side, it's going to be negative all that. So it's going to be negative x squared plus 2x plus that constant at 2. Do we know anything else about this function? Which of the following could be a function? So that means we got a negative kind of parabola here, plus 2x plus c, and we got a positive parabola. Well, I kind of would say that D might actually be our answer. And I'm mostly thinking that because this is probably going to have more of a split if that constant were the same thing. Well, you know, let's just for fun, let's say c equals 0. Then what would these two functions look like? This bottom one would be 2x minus x squared is another way to think of that. So that's 2 minus x times x. And for the top one, this is going to be x times x minus 2. So they both have plus c, I guess you could say. Still just kind of inclined to say D. So my intuition's kind of telling me here. Let's go ahead and stick with that. We'll move on. It could be E2, but it's definitely one of those two. What is the area of the region enclosed by the graphs here and here? Well, notice that if we need an area between two graphs, it's always going to be the top minus bottom. If we're talking in terms of x here, which we are, dx, from left to right. Oh, we know what the top and bottom is if we're looking at these. This negative 5x, that's going to be a function like this. And x squared minus 2x minus 2x squared, that's a negative parabola. So that means the only way that these two could enclose a space is if the negative parabola is on top. Otherwise, it'd be an infinite space in between them. So then what I need to figure out is what's these two left and right points of intersection. We usually call them like A and B. Our limits go from A to B, our limits of integration here. And then top is going to be x minus 2x squared. That's my top. And then my bottom is going to be negative 5x. So how do I figure where A and B are? I need to find where these two functions equal each other, where f of x equals g of x. Well, f of x equals g of x when those two functions equal each other. X minus 2x squared equals negative 5x. So looking at this, I would have, let's move some things around. I'll move 5x, so negative 5x to the other side. I'll have 6x minus 2x squared equals 0. If I factor out a 2x, that would give me x, or not x, that would be a 3 minus x equals 0. So if I were to plug in x, that would make those two things equal 0. If I were to plug in, or not x, if I were to plug in 0, pardon me. My brain's getting a little tired, it's getting a little late here. So if I were to plug in 0 or 3, either one of those could be x. So a must be 0, and then b must be 3. So this is really the integral from 0 to 3. Let's simplify this function here. Minus negative 5x, that's really a plus. If we put those two together, and I have x plus 5x. So that's going to be 6x minus 2x squared from 0 to 3 dx. So now I just have an antiderivative, a definite integral that I got to evaluate from 0 to 3. That's going to become 6x squared over 2 minus 2x cubed over 3, evaluated from 0 to 3. I notice that if I have all terms with an x in it, when I plug in the 0, that's going to have a minus 0 at the end. So I really just have to plug in 3. Also, the 6 and 2 simplifies to just a 3. So that's going to give me 3 times 3 squared minus 2 times 3 cubed over 3. Well, how clever is that? 3 cubed over 3 is really 3 squared. So 3 times 3 squared minus 2 times 3 squared is really equal to just 3 squared, or 9. The answer is 9. D. Do you want to go back and see that again? D. Here's the algebra. Check it out. And the simplifying. For the function f prime of x equals this, and f of 1 equals 4, was the approximation f of 1.2 found by using the line tangent to the graph of f at x equals 1. Oh, okay, so they gave us the derivative, and they're saying that f of 1 equals 4. And to find the approximation f of 1.2, it's really just a use of y minus y1 equals the slope times x minus x1. We know a y1 and we know an x1, and we're going to plug in an x and we're going to solve for y. We also know an m that we can plug in as well. So let's get our x1 and y1. Here's our x1 and y1 here. Well, that means we have y minus 4. And then on the other side, we're going to have x minus 1. We also know our slope. F prime of x equals 2x plus 1. So if f prime of x equals 2x plus 1, this is my tangent line. That means that my tangent slope, m, equals 2. So this m right here, I'm going to use that tangent slope, that's 2. Now I'm going to use the x value that they're asking me to do, which is 1.2 right here. So I have y minus 4 equals 2 times 1.2 minus 1. Well, 1.2 minus 1 is really 0.2. Multiply by that 2 and say y minus 4 equals that. 2 times 0.2 is 0.4. So I'm going to have y equals 0.4 plus 4. Or in other words, 4.4. Is that right? If I add 4 to 0.4, feel like I'm a little bit off on which ones I'm using here. Wait a second. Something's going on here. This m, this slope, m is equal to the slope at 1. That x equals 1, which is really saying f prime of 1. And we know that f prime of x equals 2x plus 1. So then f prime of 1 is equal to 2 times 1 plus 1. So that should be a 3. I knew something was up as soon as I started seeing those answers. So this should have been a 3 times 1.2 minus 1, a 3 times 1.2 minus 1, and a 3 times 0.2. So it's going to give me 0.6 plus 4, or 4.6. The answer would be D.